Hi, welcome to my video Earth Science over Meteorology by me, Carmen Green. First up is fronts. There are 4 different kinds: cold, warm, stationary, and occluded. Up first is our cold front. A cold front is when dense cold air is actively advancing into a region occupied by warmer air. As you can see, the movement of the front is pushing the warm air up. A cold front can bring thunderheads, cool temperatures, heavy downpours, strong winds, violent weather, and a sharp temperature drop. Next up, we have our warm front. A warm front is when the surface position of a front moves so that warm air occupies territory formerly covered by cooler air. It can bring gentle rain or snow, warmer or milder temperatures, light to moderate precipitation, and it could produce thunderstorms. Next up is our stationary front. A stationary front forms when warm and cold air meet and neither air mass has the force to move the other. They basically have a standoff. The weather it can bring is clouds, fog, it could rain or snow, and it could bring many days of clouds and precipitation. Lastly, we have our occluded front, which is an active cold front that overtakes a warm front. So, as you can see, the cold air, they're moving in the same direction, but the one on the left has caught up with the one on the right, and it's pushing the warm air up. It can bring temperature drops, and it can bring strong winds and heavy precipitation. Next up, we have the adiabatic process. First step in the adiabatic process is the parcel of air moves upward. As it travels up, the air pressure decreases, allowing the air to expand. When air is allowed to expand, it cools. Step 2 in this process is when the air reaches the dry adiabatic rate. This is the rate at which air cools at 10 degrees Celsius per 1,000 meters. This is also when the air is unsaturated. And remember, saturation is the maximum amount of water vapor that air can hold. Step 3 in this process. So the air will continue at the dry adiabatic rate until it reaches its dew point temperature. This is when condensation or cloud formation begins. At last, the air has reached the wet adiabatic rate. The air continues to move up, expand, and cool, and now 5 degrees Celsius per 1,000 meters. This is when the air is saturated. So now the air is holding the maximum amount of water vapor. Home stretch, y'all. For our final topic of this video, we're going to be talking about 2 processes of lifting. I've chosen orographic and convergent. First up is the orographic lift. This occurs when elevated terrains, such as mountains, act as barriers to the flow of air. Notice by my red arrows. As air ascends a mountain slope, adiabatic cooling often generates clouds and precipitation. Fun fact, as you can see by the diagram, most of the rainiest places on Earth are on the windward side of the mountain slopes where it's green and wet. And the moisture is lost by the time the air reaches the leeward side of the mountain where it's bone dry. Next, we have the convergent lift. This is whenever air in the lower atmosphere flows together and results in the lifting of air. When air comes in from multiple directions, the air can't go down, so it goes up, and it leads to the adiabatic cooling process resulting in possible cloud formation. So why is the lifting of air so important? Because without the lifting of air, there would be no adiabatic process, which means no formation of clouds, which are essential to the water cycle and us. There you have it. This has been Earth Science Meteorology with me, Carmen Green. See you next time!